This instructional video is about factoring polynomials. SSE 3 is the standard. Factoring is to factor out a greatest common factor and write as a distributive problem property. Sometimes you'll find that all of the terms have a greatest common factor. Your first step is to always look for a greatest common factor. For example, negative 5y cubed minus 10y squared. What are both terms divisible by? Look at the numbers and the variables. They're both divisible by negative 5, and they're both divisible by y squared, since both of them have at least two y's being multiplied. So I would factor out negative 5y squared, which means negative 5y squared comes to the front of the parentheses. And what do I need to multiply negative 5y squared to get negative 5y cubed? Basically, if I divide them, I see that I need to multiply by a y. What do I need to multiply by to get negative 10y squared? I need to multiply by positive 2. I can check my answer by distributing. Negative 5y squared times y is negative 5y cubed. Negative 5y squared times 2 is negative 10y squared. So this is the factored form. Another example, 10x minus 35. They do not have a variable in common since this is a constant, which means it doesn't have a variable. They are both divisible by 5, so I pull 5 out, and when I divide, I get 2x minus 7. So this would be the factored form of that binomial. One more example, 2a squared b plus 12b squared. Look at both the numbers and the variables. They're both divisible by the number 2. And what variables do they have in common? This one doesn't have any a's, but they both have at least one b. So the greatest common factor is 2b. Factor out 2b, and what's left would be a squared plus 6b. Check your answer. 2a squared b is what I get when I multiply here. 12b squared is what I get when I multiply there. So this is my factored form. So that's just a little bit of a discussion about a greatest common factor. But the majority of the problems you're going to be factoring in this unit are quadratic polynomials. Quadratic polynomials are polynomials that have an x squared. The standard form for quadratic polynomials is ax squared plus bx plus c. Recall multiplying binomials like x plus 2 times x plus 3. We had to distribute twice. We had to multiply the x times the x times the positive 3. So that's distributing the first term and everything in the parentheses. So that's x squared plus 3x. Then we had to multiply the second term, positive 2 times x, and positive 2 times positive 3. So
Good morning, everybody.
Positive
have a
2x
request
plus
that if you have
6.
any non-refrigerated items for the barbecue cookout today, please bring them to the cafeteria. If you have any non-refrigerated items, please bring them to the cafeteria. Thank you.
Notice that we added the two middle terms to get a sum of 5x. The positive 6 came from multiplying the positive 2 and the positive 3 to get a product of positive 6. Positive 2x and positive 3x gave me a sum of 5x and a product of positive 6. We're going to use that information as we talk about factoring polynomials in the form ax squared plus bx plus c. The strategy I'm going to use is called, I call it Lizzie's method, you can call it the diamond method, but write this down. This is our formula. We're going to have a product of a times c. So I'm going from standard form. A is the coefficient of x squared, c is the constant. We're going to have a sum of b. B is the term, the coefficient of the x term. And then this portion right here, when we get two numbers that have this product and this sum, we divide by a. So write that down, that's your formula. We're going to come back and use that, write down both standard form and the formula here. So let's do an example. If I wanted to factor x squared plus 5x plus 6, a equals 1 because that's the coefficient of the x squared term, b equals 5, and c equals positive 6. Diamond, so I'm going to be dividing by a, which is divide by 1. I have a product of a times c, 1 times 6 is 6. I have a sum of 5. Now, this is where you have to come up with what two numbers have a product of 6 and a sum of 5. Some are more simple than others. So here we would use 2 and 3. So 2 and 3 are the numbers that we are going to be putting in our binomials, which represent our factored form. The denominator becomes the coefficient of x, so that's 1x plus 2 and 1x plus 3. And we can multiply that out to see that we get x squared plus 5x plus 6. So we would call this the factored form of this trinomial. This is the factored form. Let's do another one. X squared minus x minus 12. Here a is still 1, b is negative 1 since it's minus x, c is negative 12. The sign in front of the term tells you if it's positive or negative. So I'm going to have divide by 1. A times c is my product, so negative 12. My sum is negative 1. So what multiplies to give 12? 1 and 12, 2 and 6, and 3 and 4. Since it's negative, I know one of my factors is going to be positive and one of my factors is going to be negative because that's the only way to multiply and get a negative number. And since the sum is negative, the bigger factor is going to be the negative number because when I add these two, the leftovers are negative. So what has really a difference of negative 1, since when you're adding a positive and negative, you subtract and take the sign of the larger number. So it's going to be positive 3 and negative 4. So again, the coefficient of x comes from this denominator when it's in simplest form. So we have 1x plus 3 times 1x minus 4, and that is my factored form. This strategy really becomes helpful when you have a leading coefficient, an a value, something other than 1. Let's look at 2x squared plus 11x minus 13, for example. Here we get a is equal to 2, b is equal to 11, and c is equal to negative 13. So when I create my factor tree, I'm going to have a times c. A times c, 2 times negative 13 is negative 26, and b is 11. Then when we divide by a, here we're going to put divide by 2. What two numbers have a product of negative 26 and a sum of 11? So we can list our factors, 1 and 26, 2 and 13, 3, 4, 5, 6, 7, 8. 26 is not divisible by any other numbers. And I thought through it in a logical manner, starting with 1, going to 2, 3, 4, 5. Always helpful to include all your factors. Again, we have a negative product, so we're going to have a positive times a negative, which means we're really looking for a difference of 11. So 13 and 2 are my numbers. Which one needs to be negative? Since we have a positive sum, the smaller number will be negative. So I see that my factors are 13 and negative 2. Here's where we need to divide by 2 if possible. These only need to be in simplest form. So here we can simplify, and this becomes negative 1 over 1. This cannot be simplified, so this is still 13 over 2. The denominator becomes the coefficient of x, so I have 2x plus 13 times 1x minus 1. You can always check your answer by multiplying 2x squared minus 2x positive 13x minus 13 would simplify to 2x squared plus 11x minus 13. So this right here is my factored form. One more example. I'm going to do an example of a problem that has a negative leading coefficient, negative 2x squared plus 5x plus 42. You have two options here. You could factor out a negative 1 so that when you're factoring, you have a leading coefficient that's positive. Or we'll talk about how we would use our same strategy and still use an a value of negative 2. Let's look at that. B equals 5, C equals 42. So I'm going to do my factor tree. I know I'm going to be dividing by negative 2. I have a product of a times c, so negative 2 times 42 is negative 84. And I have a sum of b, which is 5. So I'm going to think through my factors of 84. What multiplies to give 84? 1 times 84. 2 times 42. 3 times, and the sum of 8 and 4 is 12, which means 84 is divisible by 3. 3 times 28. 4 times 21. 5, no. 6 times 14. 7 times 12. I'm closing the gap as 7 and 12 are getting closer together. 8 is not a factor, 9 is not a factor, 10 is not a factor, 11 is not a factor. So that's listed all of my factors of 84. Which pair of factors has a sum of 5? Keep in mind I have a negative product, so one's positive and one's negative. So I would use negative 7 and positive 12 because they have a difference of 5 since they're different signs. So now I simplify if possible. 12 over negative 2 simplifies to negative 6 over 1. So I know one of my factors is x minus 6. Again, the denominator becomes the coefficient of x. I don't need to write it if it's a 1. Here, remember that this first term is a negative 2x squared. So x times a negative number is the only way to get a negative 2x squared. This cannot be simplified, and we are going to leave it as a negative over negative, meaning negative 2x squared minus 7. Both of those negatives are needed in order to multiply and still get that negative 2x squared. A quick check is to do x times negative 2x squared. That does give me negative 2x squared. X times negative 7 gives me negative 7x. Negative 6 times negative 2x is positive 12. So negative 7x and positive 12x gives me 5x. And negative 6 times negative 7 is positive 42. So this does check, and when multiplied gives me the original quadratic. Good luck.